everyone. Can you hear me well? Can you hear me well, guys? Okay, very good. So please get prepared. We start in 1 minute. Today's lecture is very, very easy. We have two small ideas and that's it. And don't forget, guys, so it's 12:15. So guys, don't forget next week. What do we have next week? ICA 2. At what time? Tuesday. It will be 26, right? And what are the chapters? 5.1, 5.3, and we need also 3.6. Okay. 3.6, we need only the standard basis. Today we will talk about it. So today you will know what you need from 3.6. So guys, let's wait again 1 minute. Okay, it's 16. Please click on yes for present. Alia, Asrar, Jinan, Mariam, Naima, Sarah Zavi. Okay. Okay, very good. So Jinan Kandari and Sarah Zavi, please click on yes for present. Okay. So can you see the presentation, guys? Very good. So guys, already we have defined the linear transformation. So we have seen everything about linear transformation, definition, what are the conditions for linear transformation, everything, and especially we have seen that if we have LU plus V, it's equal to LU plus LV by definition, and L any number CU it's equal to CL of U. So we have seen everything about it, and today we will talk about standard matrix of linear transformation. So we'll talk about matrix. Today is, yes, if you want this lecture all together, 5.1, 5.3, it's mixed. So if you want 5.1 is linear transformations, 5.3 is matrices. But in fact, they are all chapter 5. What I want is, look, this is the title, for linear transformation and matrices. Both of them are 5.1 and 5.3. So it's mixed. Okay, now, so if we have a linear transformation L from E to F, so this is a departing vector space and arrival vector space, what we need for standard matrix, to define the standard matrix, we need the natural basis for E. Natural basis for E, or what do we call instead of natural basis? We call it standard basis. So what we need is standard basis, and we have seen before standard basis for Rn and standard basis for Pn. So if we take the standard basis of the vector space E, pay attention only for E, not for F. We don't care about F. Then you have to find output of E1, output of E2, output of En by order. You put them by order, you put them by column, you get the standard matrix. So this is the standard matrix of L, the standard matrix representing L. Okay, guys? And what's important in this matrix, if you want to find L of any vector, you can, so to find the output, you take the matrix A, you multiply it by V, this is the input. So if we have input here, to get the output, you multiply matrix by input, you get the output. So let's directly take an example to understand what's the meaning of this one. Okay, Khalifa. Look, guys, let's read. We have example 11, page 340. We have L from R3 to R squared defined by, you see, input, if u, we have L of u, correct? So the input is from R3. Input is 3 components, output is 2 components. L is a linear transformation, so we are not telling you to prove if it's a linear transformation or not. Directly, we know it's a linear transformation. So find the standard matrix representing L. Yalla guys, always, to find the standard matrix, you have to take the standard bases of which space? R squared or R cube or R squared? Very good. Standard bases for R cube for the starting space. Yes, Rawan? Okay, Rawan, yeah, for sure, no problem. So, what's the standard basis for R3? The first vector is, you have to put them by order, guys. What's the first one? It's standard, you have to keep the same order. Yes, but what's the components? We have 3 components. Standard basis is 3.6. Yes, 1, 0, 0. Second one, E2 is 0, 1, 0, and E3, 0, 0, 1. So this one is 3.6. So you see why we need 3.6? We need 3.6 to know what's the standard basis. Now, let's find output. Output LE1, LE2, LE3. So L of 100. Yalla guys, find L100. Find the output of 100, 010, and 001. Yalla guys, what's the output of this one? Look here. What do we have? We have U1 equal 1, U2 0, U3 0, correct? So means find how many U1 we have in the first component here. How many U1 do we have? 1. Here, how many U1? 0. Now, we have to look on U2. We have only 1 U2. So how many U2 do we have? 2. Look, it's 2 U2. And here, how many U2? 3. Here, U1 is equal to 0, U2 equals 0, and U3 equal 1. Means you look only on U3. How many U3 do we have? Here we don't have the first row. And here U3 we have 3. Minus 2. Very good. So to simplify, you put U1 0, U2 0, U3 equal 1. You substitute, you get 0 minus 2. So the standard matrix A representing L is A equal LE1, LE2, LE3, and we substitute. So what do we get? We get 1, 0, 2, 3, 0 minus 2. Look, what's the size of this matrix? Two by 3 matrix. You see, look here, it's 2 by 3. So not 3 by 2. Yes, Hamad. So to find the standard matrix, we have to find, please follow me all of you. We have first of all, we have to find the standard basis from 3.6. It's 100, 010, and 001. Okay? Clear for this one? Clear up to here? Okay. Now, we have to find output. What's the output of E1? LE1 is L100. Put instead of U1, put 1, U2, 0, U3, 0. What's the output? It's the first plus 2 multiply second. So first it's 1 plus 2 multiply 0, we get 1. Here, 3 multiply second, so 3 multiply 0, it's 0. Minus 2 multiply last one, minus 0, 0 minus 0, 0. Clear for this one? This is input output as we did before on Tuesday. Now, LE2, L010. So we take first plus 2 multiply second. First, 0 plus 2 multiply 1, 0 plus 2, 2. Clear? Now, here you take 3 multiply second minus 2 multiply last one. Minus 2 multiply third. So 3 multiply second, 3 multiply second, 3 multiply 1, it's 3. Minus 2 multiply 0, nothing, so 3. Clear? You do the same for LE3. So the standard base matrix by definition is LE1, LE2, LE3. You put them, you have them here, LE1, LE2, LE3, you get this matrix. Understood? Understood, Hamad and Abdullah? Okay. So this one was from the previous previous lecture. Just here you put them by order, LE1, LE2, LE3. Why LE1? Because here the standard basis is 1, 2, 3. Too simply. Please take screenshot because I will erase and I will tell you why we use this matrix. So please don't forget, next Tuesday we have ICA 2. The last in-class assignment is 60 minutes, as we did before. You need civil ID and a UM card. Yes, question is done, because look, what's the question? Find the standard matrix. We did it, finish. This one, we get it. And it's 2 by 3, look, always it will be 2 by 3. So second multiply first matrix. So, let's erase here. Okay, Rowan. So here we get the matrix A, which is this one. So like this, we answered the question. So here, the standard matrix, find the standard matrix presenting L is this one. Now, guys, look, I will add find L. Give me any input. Input, it must be 2 or 3 components. Okay, 4, 8, 4, 5, 8. So, using definition and using the standard matrix A. So, using definition, guys, means using this one. This is definition. So let's find. You have input 4, 5, 8. Find output. What do we get for output? So we take first plus 2 multiply second. First, it's 4 plus 2 multiply second. So what do we get? 14. Clear, guys, all of you, why it's 14? Now, we take 3 multiply second. So 3 multiply second, it's 15. Minus 2 multiply last one. Minus 16. 15 minus 16. Minus 1. Now I will use the standard matrix. Look, guys, L 4, 5, 8. To find the output, as I said here, what do we put to find the output? You take the matrix A, you multiply it by the vector. So here, you take the matrix A, multiply the vector, 4, 5, 8. So what's the matrix A? It's 1, 0, 2, 3, 0 minus 2 multiply 4, 5, 8. And we must get the same. Let's see. Multiply row by column. 1 multiply 4, it's 4 plus 10, 15 plus 0, 14. Here, 0 plus 15 minus 16 minus 1. Look, did we get the same? So if you have definition, you can get standard matrix, and if you have standard matrix, you can find any output. Is it clear? Because usually for computer, we give matrix, we give any vector, it gives us the output. Clear? Is it clear, guys? Very good. Please take screenshot, guys, so we continue. So this one I added. It's not from the question, just I add, okay? Okay. Now, look, guys. This one, I think everyone will answer it, correct? So, here, guys, we have the matrix, we have the standard matrix. You see, A is the standard matrix representing the linear transformation R3 to R3. You see why it's 3 by 3? Because look here, 3 by 3, okay? So it's the standard matrix. How to find L2 minus 3, 1? So how to find this output? Usually here we put brackets. So how to find it, guys? We multiply this vector by, here, what should we put? A, too simply. You take A, multiply this vector, you get the output. So it's 0, negative 1, 2, negative 2, 1, 3, 1, 2, negative 3, multiply 2, negative 3, 1. So multiply, guys, row by column, row, column. So what do we get for the first one? Yalla, guys, multiply. 0 plus 3 plus 2, 5. Very good. Second one, minus 4, minus 3 plus 3, minus 4. Very good. Last one, 2 minus 6 minus 3, we get 7. 2 minus 6 minus 4 minus 3. Very good. Minus 7, right, Abdullah? Yeah, very good. Is it clear, guys, all of you? So we see, if we have the matrix, directly we can find the output for any vector. Even we can find the definition. Here, look, this definition. Also, it's A, U1, U2, U3. So it will be 0, negative 1, 2, negative 2, 1, 3, 1, 2, negative 3, U1, U2, U3. Multiply, so it will be 0, U1 minus U2 plus 2, U3. Second one, is 2u1 plus u2 plus 3u3, isn't it? And last one, we multiply this row by this column. 1 multiply u1, so it's u1, plus 2 multiply u2, very good, minus 3 multiply u3, very good. So you see, even if I have standard matrix, I can get definition, and if I have definition, here definition, I can get the standard matrix. So in finally, standard matrix and linear transformation are the same. One gives the second one, okay? They are equivalent. Is it clear, guys? Very good. It's easy, right? Nothing difficult. We don't have any new ideas. Very good. Okay, let's continue. I think you took screenshot. Okay. So you see, you have here everything. For polynomials, keep it for the moment. Okay, here. Look, guys. What part A? This one, Nora? Yes, you just L of u equal to AU. Clear? Definition, always. Now, you take matrix, multiply vector. This is chapter 2, even chapter 1. You multiply row by column. Here, dot product. 0 multiply 2 plus minus 1 multiply minus 3 plus 2 multiply 1, you get 5. And so on. Okay, Nora? Same, Abdullah. What? Multiply. Row by column. 0 multiply u1, 0. Minus u2 plus 2u3. Look, it's here. Yes. So what's your question? If you know. Okay, thank you, Nora. You are explaining. I thought you are asking. Explain how it's done. Okay, Abdullah. Yes, but yes, you are right. For any vector, it's given by you multiply. But in all cases, if you have any vector here, you take A multiplies this vector, you get the solution. Okay, I understand your point. So, guys, here what do we have? We have L from R2 to R2. Here, tell me, the standard matrix will be what? A will be which size? 2 by 2. Very good. So it's 2 by 2. If I have here 2 and 3, it will be 2 by 3 or 3 by 2? 3 by 2, very good. No, 3 by 2, Nora. Always 3 by 2. The last multiplies first. Okay. Now, we want to find the representation of L with respect to S. What does mean S? S is the natural basis of R2, for R2. So here means the standard basis. In ICA, I will tell you always standard basis, standard matrix. Okay, guys? It's better. Standard matrix. A. So, guys, to find that first, we need the standard basis for what? For R2. For this R2. For R2 is, yalla guys, what's the standard basis for R2? You have to put them by order. Pay attention, by order. 1, 0. Don't put 0, 1 first. And E2, 0, 1. Very good. Very good. You have to keep by order. Even if it's a set, you have to keep by order. For that, we call it standard. Standard means by order. 1, 0, and then 0, 1. Okay? Not the inverse. Now, we need how to find the standard matrix. A is, too simply, A will be, we take the output of this one, so LE1, LE2. Correct? So let's find LE1. LE1 means L10. So what's the definition? You take first plus 2 multiply second. So it will be first plus 2 multiply second, 1. Here, 2 multiply first minus second. 2 multiply 1, 2 minus 0, 2. Very good. LE2, it's L01. So it will be, so first 0 plus 2 multiply 1, so it will be 2. Here, 2 multiply first, so 0 minus 1. So A will be LE1, which is 1, 2, LE2, 2 minus 1. Clear, guys? You see, very, very easy. Very good. Yeah, with respect to the natural basis, if you have here natural basis means standard basis, right? So for that, yeah, it's standard matrix. Correct. If we don't have natural basis, means not necessarily standard matrix. Standard matrix means the representation with respect to the standard basis. But as I told you directly, I will tell you standard, so no need to show this one. But yes, you are right. The representation with respect to S, and S is the natural basis, means the natural matrix or the standard matrix. Natural and standard means the same. Understood, all of you guys? Okay. Nora, clear? Okay, yeah, you said clear. Okay, okay. So let's continue. Okay, this one is very important, guys. But for sure, if I will ask you something like this, I make it 2 by 2. So here R2 and R2, it's easier. Not easier, just faster. Both are easy. This is what I want to say. So guys, here I will write, very important. In fact, all are important because, you know, for ICA you have true, false, multiple choice, and workout. So means all of them are important, okay? For sure, I will ask from everything. So guys, but I will not ask you standard basis for polynomials, okay guys? I will ask, for example, what's the standard basis for polynomial if you have similar like this one. Remember the last exercise we did like this one. You have input, output. Remember this exercise? Also you took screenshot. I don't ask something very complicated, especially for ICA. Okay guys? Where is it? Okay. Look guys. Abdullah. We have L from R cube to R cube defined by L of 100. What does mean 100, guys? This is the input, but what does this vector? Very good, it's E1. 010, it's the second component of the standard basis, and here third component of the third basis, of the third component of the basis. So you see, I have LE1, this one is LE1, this one LE2, this one LE3, correct? Find the representation of L with respect to the natural basis. Means, is it the standard basis? Here, if we have the standard basis, means, is it the standard matrix? Find the representation of L means, yes, the standard basis matrix. Standard matrix A. Let's call it A. So guys, yalla, let's answer. First of all, we have to write the standard basis of R3. Standard basis for this guy, R3, is, what's the standard basis? E1 equal to 100, E2 010, and E3, we have only 3 because dimension is 3. 001. Now, the standard matrix will be LE1, very good, LE2, LE3. We have all information, correct? We have everything, so what do we get? Where is LE1? Is it 100 or 110? 110, very good. LE2? 201. Pay attention, Nora. This one, LE1. Look, read LE1 equal to this one. So this one is LE1. This is the answer of LE1. This is the answer of LE2, and this is the answer of LE3, 101. So now I have the standard matrix. Is it 100% understood? Yeah, it's given like this. Here all given, and here solution. So please take screenshot. Let's make part B. Okay, let's erase. So here the standard basis is this guy here. Correct? Now I have the standard basis matrix. Now I want to find L123 using definition. I don't have definition. Do we have definition? So we will see how to do it later. And using the matrix obtained in part A. How to find it using the matrix, guys? How to find L123? We multiply multiplication, very good. A multiply 123 means 1 2 1 1 0 0 0 1 1 multiply 1 2 3. Multiply, guys, what do we get? Row by column, row by column, row by column. Yeah, guys, please give me all components. Eight, 6, 1. Okay, let's check. 1 multiply 1, 1 plus 4, 5 plus 3, 8. Very good. The first one is correct. 1 plus 0 is 1. And last one, 0. 0 multiply 1 is 0. plus 2 plus 3, 5. 815. Very good. Very good. Please take screenshot because I will erase and then we have definition. We need to have it. No, Abdullah, no need. No need. I will tell you how. So I will erase, guys. Guys, look here. So this one we did it. We are done. Now, using definition. Guys, do you agree with me if we have U1, U2, U3, it's equal to U1, 1, 0, 0, plus U2, 0, 1, 0, plus U3, 0, 0, 1, correct? Always we can write as U1, E1, plus U2, E2, plus U3, E3, correct? Nothing, we didn't do anything. So in particular, 1, 2, 3, it's equal 1, E1, plus 2, E2, plus 3, E3, isn't it? So using definition, so L 1, 2, 3, it will be L of everything here inside, 1 E1 plus 2 E2 plus 3 E3. And because L is linear transformation, I can cut it, right? So it will be L 1 E1 plus L 2 E2 plus L 3 E3. Because we know that L is linear transformation, Lu plus V is equal to Lu plus Lv, correct? So erase this one because this one is nothing. Isn't it, guys? Now we know that L, so here Lu plus V equal to Lu plus Lv. Here we use it here. And we know that LCU, if we have constant, I can put it outside. It's CL of U. I will use it here. So put one outside, 1 Le1 plus 2 Le2 plus 3 Le3. Here y plus, because look here already we have plus. If I have minus, you put minus. So I will get 1 multiply Le1, which is 110, plus 2 Le2, which is 201, plus 3 101. Please do it. What do we get? 1 plus 4 plus 3, 8. 1 multiply 1. Now look on the middle. Second component. 1 plus 0 plus 0, it's 1. Last component, 0 plus 2 plus 3, we get 5. So this is how we do it using definition. Understood, guys? So here using definition means we use definition of linear transformation, we split it, and we put the constant outside, and respecting the sign. If it's plus, we keep it plus. If it's minus, we keep it minus. Please take screenshot and let's continue. So, no question, guys? Okay. We still have only one exercise, guys, and then I will give time for your questions if you have. So you see, today's lecture is very, very easy. It's about basically standard matrix. Yes, absolutely, Nora. If you have similar, if I ask you using definition, if I don't ask definition, I ask only matrix, you use the one before. You multiply matrix by the vector. Not necessarily, but because here we are using look. Look why I said important, because look here, I use definition. Look, I use definition. I use standard matrix and everything. Here we used everything, 5.1, 5.3, right? Okay, Abdullah? Why not? Even in assignment, I can ask, because it's very easy. It's not difficult. Nothing difficult in this chapter. For sure, you will have questions similar, because you have true, false, multiple choice, and workout problem. So for sure, you will have something similar. This is the last question, guys. Okay. So here we want to find, what do we have? Let's read. We have L from R3 to R3, so the standard matrix will be 3 by 3, which is correct. B linear transformation represented by the matrix with respect to the natural basis. So this one, is it a standard matrix? Yes, A, the standard matrix. Now, let's find L1, 2, 3. Too simply, we take A multiply 1, 2, 3. So it will be very good. 1, 3, 1. 1, 2, 0, 0, 1, 1, multiply 1, 2, 3. Yalla, guys, give me all components. How come? It's 10 first. So 1 plus 6 plus 3, it's 10. And then 5, correct. And the last one, 0 multiply 1, 0, plus 2 plus 3, also 5. So 10, 5, 5. Second one, L0, 1, 1. So again, it's 1, A, 0, 1, 1. So it will be 1, 3, 1, 1, 2, 0, 0, 1, 1, multiply 0, 1, 1. Yalla, guys, what do we get? 4, correct. Second row, multiply column. 2, very good. And last one, last row, multiply column. Again, it's 2. Very good. So you see, we are done with chapter 5. Standard matrix was the last idea, and how to move from linear transformation to standard matrix, how to find the standard matrix, and how to move from standard matrix to get definition, or how to find the definition, or how to find output using standard matrix. So we are done. This is everything for today. Don't forget, guys, next week, first lecture on Tuesday, we have ICA 2. Please get ready for the ICA. It will be very easy, and please don't miss it. Thank you very much. If you don't have any question, yes, standard, yeah, you need only standard natural basis, correct. What's the natural basis for Rn, R2, R3, R4, natural basis for P1, P2, P3? Like, look, what's the natural basis for P3? P3 is what? It's t to the power of 3, t to the power of 2, t1. So just to remember all these, the natural basis. Yes, this is what you want. Because here, as you have seen, we need only the natural basis to define the standard matrix. Thank you. Enjoy your weekend, and please be ready. First lecture, we have ICI 2. Thank you very much. Enjoy.